Hola guys, welcome back to my channel. So this is the continuation of the previous question. So this is question number 2 basically. So this is still in the probability chapter. And yeah, let's get into the question. In a survey conducted towards 500 respondents, 45% of them are married. Okay, so let me highlight it. Married. Okay. One fifth means 20%, right? 1/5. 1/5 times 100% is 20%. So this is basically 20% of the respondents, which is 500 respondents total, are single male. There are equal numbers of male and female respondents involving in the survey, which means that the male is female. So maybe I can use the alphabetic word like M and F to indicate male and female. So male is equal to female, which is 250. Okay, so we are required to construct an appropriate contingency table. So it is just a normal table that you always seen like this, right? So let me make for you the table. Okay, so this is just a normal table that okay. So okay. Okay, so where I want to put my gender is maybe over here. So this is male, female, total. So this is married, single. So this is total. T will stands for total. Okay, total number. So let's analyze. So 1/5 of the respondents are single male. So 1/5 of the respondents, which means 1/5 times 500 is 100. Okay, 100 respondents of single male. So male and single. So male and single is this box, which is 100. Okay, but you know that there are 250 male in total. So we know that the total of male in this column is 250. So the remaining is just the difference of 250 and 100 is 150. Okay, just fill in inside the box. Okay, the next information is 45% of them are married. So 45%, 45 over 100 are married, which means that 45% out of 500. Okay, so this is how much? 45 over 100 times 500 is 225. Okay, so 225 is married. So regardless of the gender. Okay, regardless of the gender. So married is 225. So the total number of married is 225. So okay, so this row, okay, the total is 225, like that. So if you want to find this value for the married female, it is simply the difference between 225 minus 150, which is 75. Okay, because we know that the total female should be 250 also. So if you want to find this value of single female, it is just the difference between this and that. Okay, 250 minus 75 is 175. So when you evaluate this total single, it should be 100 plus 175. So you just add up this what we call this row. Okay, 100 plus 175, which is 275. Okay, and the total should be 500. Okay, so make sure that your total is consistent with the question, which means that when you add up the total over here, 250 plus 250 is 500, and then this column is 225 plus what 275 is 500 also. So they are consistent, so which means that we are doing fine. Okay, so yeah, this is the final table that we constructed. Okay, like this. Okay, alright, so okay, question A done. So for question B1, so the respondent is married female. Okay, married female. B1, married, so married is here, and also female, which is 75. Okay, so we want to find the probability. The respondent is married female, so probability of female and married is probability of, which is 75 over the total respondents is 500, which is 75 over 500. 3 over 20, is it? Let me check. Is it to 320? Okay, yes, it is 300. Sorry, 3 over 20. 3 over 20. Okay. Alright, so question 2 is the respondent is female if it is known that she is single. So the respondent is female given that she is single. So this is using Bayes' theorem, so it is P F intersection single divided by probability of single, which is F and single, female and single, is 175 divided by the probability of the single. Okay, probability of this single is this part, right? 275. Okay, 275. So this is basically over 500 and also over 500. Okay, because this is talking about probability, so the 500 cancels out, so this becomes 175 over 275, which is simplified to be 7 over 11. Okay. Okay, the respondent is a male, so probability of the respondent is male given that she is married. He is married. So this is probability of male intersection married. Okay, divide by the probability of the married respondent. Okay, so male and married is, according to our table, male and married is 150. Okay, so it is 150 over the total respondents because we are looking at the probability, and the probability of married is basically this one. Married is 225 divided by 500. Okay, 225 divided by 500, so 500 cancels, so we just leave with 150 divided by 225, which is simplified to be 2 over 3. And the last one is the respondent is married, given that the respondent is male. So the question translates to be respondent is married, probability that a respondent is married, given that he is male. Okay, is the probability of married intersection with male. So male is M, right? So I will use M instead. So P married intersection with M divided by P probability of M. So probability of married and male, so we have looked for it previously, which is married and male is 150 over 500 divided by probability of the male itself. The probability of male is 250, right? 250 over the total respondents, so the 500 cancels, leaving us with 15 over 25, which is 3 over 5. Right? So that's all for this question number 2. Alright, until next time, goodbye and thank you.